letter arrangements. So with letter arrangements, we know that we will always work with a lot of our fundamental counting principles. So to somewhat showcase a few examples, a few ways that you want to deal with questions that ask you to work out the number of ways that letters can be arranged or something like that, we need to think of a word. So let's think of a long word, but not too long. So the word or words that we're going to use is zero aesthetics. And this time I'm going to spell aesthetics correctly, because on my math page I actually spelled aesthetics incorrectly, but then I just left it like that because, you know, it is what it is. So let's use the word aesthetics, or rather zero aesthetics, and work on how many ways that phrase can be arranged, or how many ways the letters in that phrase can be arranged. There we go, zero aesthetics. Zero aesthetics. So my math page on IG is actually called zero aesthetics underscore just mathematics. There's no E there. That is deliberate now, but initially that was actually a misspelled word because spelling. Yeah, if you're good at spelling, let me know in the comments. If you're not, let me know in the comments. Let's see how many of us there are that are just so bad at spelling that we have just learned to live with it. So letter arrangements. We know that with a word like this, let's pretend this is just one long word. If we are asked to work out the number of ways that these letters can be arranged without any restrictions, we know that if there are no restrictions and we had to work out the number of ways that these letters can be arranged, all we need to do is we firstly just need to know how many letters are we working with anyways. So in our case, we're working with 14 letters there. So with these 14 letters, the number of ways that they can be arranged with no restrictions is just 14 factorial ways, of which 14 factorial is quite a big number. So that's how many ways these letters can be arranged if there are no restrictions. If we do have restrictions, however, say they ask us how many ways can these letters be arranged if your word has to start with a Z and end with an S. With a situation like that, or a scenario like that, we know that all you want to do is you want to pretend that your word actually only has 12 letters, where Z is in front and S is at the end there. So if you need to work out the number of arrangements if your word has to start with Z and has to end with S, all you do is you fix Z in the start, you fix S at the end, and then in the middle we know that you have 12 letters left. Now those 12 letters will obviously only be arranged 12 factorial ways. So for a scenario where you have to start with Z and have to end with S, you can only arrange your letters in 12 factorial ways, because this is fixed. In the middle, these can be arranged in 12 factorial ways, and then at the end there's only one option there. So here, the number of ways that can be arranged would just be 12 factorial. Now another scenario is if, for example, they tell us how many ways can our letters be arranged if 0 has to be together and aesthetics has to be together. So let's think of that scenario. So for a scenario like that, we have to remember what we spoke about when we were dealing with two different brands, and we spoke about how many ways we need to arrange those brands if one brand had to be together and another brand had to be together. So that's the same ideology here. We have the word or words, or in my case, we have a phrase here, zero aesthetics, and they want us to work out how many ways can these letters be arranged if 0 has to be together and aesthetics has to be together. So the one thing to take away from this kind of a question is, firstly, 0 has 4 letters. Aesthetics has 10 letters. Now, if 0 has to be stuck together and aesthetics has to be stuck together, it means that the number of ways that your letters can be arranged is going to be 4 factorial times 10 factorial times 2, because there's obviously a scenario where the letters in aesthetics come first and then the letters in 0 come after. And there's a scenario where the letters in 0 come first and then the letters in aesthetics come after. So the one thing to take away from these 3 scenarios is that with our questions, each individual letter was taken as a different letter. What I mean is, you see there are 3 E's here. However, with all these questions here, for all this to be valid, our question would have stated that each letter is to be considered as a different letter. You get? So all these would be valid. Now we are going to work with scenarios where a letter that repeats should be disregarded. Now, in our previous set of examples, we were not treating repeated letters as identical. We were treating repeated letters as individual letters on their own, of which you have questions like that. However, with questions where you need to treat repeated letters as identical, that basically refers to a scenario where if they ask us to work out how many number of ways 0 aesthetics can be arranged, what we would need to do is we would need to consider how many letters we're dealing with and how many letters repeat, you see. So for example, if they were to ask us how many arrangements can be made if repeated letters are treated as identical. So the keyword here is identical. With our previous examples, the questions could have easily been worded out in such a way that says how many arrangements can be made if the repeated letters are treated as different, you see. So in cases where our repeated letters have to be treated as identical, as in our repeated letters are not standalone, questions like that, this is what we need to do. For our phrase here, the number of ways that these words can be arranged, or the number of ways that these letters can be arranged, is 14 factorial ways. However, we have to divide this 14 factorial by the number of letters that repeat, in the sense that E occurs 1, 2, 3 times. So down here, we have to divide the 14 factorial by 3 factorial, and then R does not repeat. O, no. A occurs once, S occurs twice, T twice, H once, I once, C once. So our number of arrangements that can be made if repeated letters are treated as identical is just going to be 14 factorial divided by 3 factorial times 2 factorial times 2 factorial. Now in your calculator, you are going to have a very big number there. So this is, oh, it's not that big. It's 363,242,800. So that's how we would pronounce, or that's how we would say out that number. 363,242,800. See, so that's how many ways that these letters can be arranged if repeated letters are treated as identical.